Hi everyone! Today we're going to be getting started with linear equations. And the first thing we want to start with our linear equations is slope. So, what is slope? As we can see, the slope is a ratio that compares the vertical change to the horizontal change in a line. What? So, what does that mean? Well, because we are talking about lines, we need to know lines can do one of four things. So there's four different types of slope, and we're going to talk about the four different ways that these lines can slant. So the first way, if we look, there's an upward shift of the line, and this is going to be what's known as a positive slope. If we look, the second line is going downward, so obviously we think that it's going to be a negative slope. Positive and negative slopes are actually pretty easy to identify. We notice that if it goes up, it's positive, and if it goes down, it's negative. But if we look, there's two other things that the lines are doing. One of them is it's just lying flat, going straight across our coordinate plane. This is what we call a zero slope. And we'll find out later when we start solving and finding the slope why that would be a zero slope. And the last type of slope we have to identify is this vertical line here. It's important that we realize that we have horizontal lines that make our zero slope and our vertical lines that make our last type of slope, which is called an undefined slope. And again, once we learn how to find those slopes using the formulas, we'll realize why it's called an undefined slope. So there's three different ways that we can find slope. The first way we're going to find slope is from a graph. If we look at our first example here, we can see the graph of this line. Again, linear equations are going to produce lines. When we're trying to find slope from a graph, earlier in our definition, we said that it was our vertical change versus our horizontal change. When we're looking at a graph, we call this the rise over the run. Notice it's a fraction. This is going to be important. And our rise is just that vertical change, and the run is going to be the horizontal change. So if we look at our first point, again, we can start with either of these 2 points. I just like to start off at the bottom point. If we wanted to, we could name this point. The coordinates would be 2, 1. So how do I get from 2, 1, that bottom point, to this top point, 5, 3? The way I do that is I have to rise. Again, when we move along the coordinate plane, we have to work in a particular order. So I'm going to rise 1, 2 places to get here, and then I'm going to run 1, 2, 3 places to get to this next point. So I went up 2 and to the right 3. This is important when we're trying to find the slope. And I know I made a mistake right there. Sorry. So again, when we look at this, our vertical change, how many did we go up? Well, we went up 2. And what was our horizontal change? Which way did we go, left or right? I went right 3. Since up and right are positive, we know this from our coordinate plane, we know that this is going to be a positive slope. Let's look at our next example. Okay, if we look at this graph here and we wanted to name our coordinates, of course we can. This is going to be -2, 3, and our top coordinate is going to be 3, 5. So I'm going to, again, start with my bottom point. We could always start from the top point. It's not going to make a difference. And I'm going to move up 1, 2 places. So I rise 2, or I went up 2. And this time I'm going to move to the right 1, 2, 3, 4, 5. So I move 5 right. Again, because our slope is our vertical change over our horizontal change, when I look at this one, vertically, I did go up 2 and to the right 5. If we notice, these are both going upwards, so we expect them to have positive slopes. When we look at our actual slope, we do see that it is in fact a positive number. All right, let's check our third example. First thing we want to notice about this third example is it looks a little different than both of our first and our second examples. We notice that this time the line is going down. We learned previously that a line that's going down is going to have a negative slope. So we expect the number that we get when we find this slope to be negative. Again, we can start off at either point. This time I'm going to start off at my top point. I'm going to move 1, 2, 3, 4, 5 places down. So I went 5 down, and now I'm going to move 1, 2, 3 places to the right. So 3 right. Well, because we went down, down would imply a negative number. Therefore, when I write my slope this time, it's going to be a negative 5 over my run. I still went to the right, so that's a positive 3 would be a 3. So again, my slope is negative 5/3. If we want to go ahead and clean that up, we can make the fraction negative 5/3. That way it looks like a fraction that we're more used to seeing. The next way we're going to find slope is given 2 points. So we already saw in our graph that we can write our coordinates. If we look, we know from our coordinate plane that if we have coordinates such as -4, 3, and 2, -6, I can label these. So I'm going to label my first coordinate x and y. Since it's my first coordinate, I'm going to actually call that x1, y1. And my second coordinate, since it's my second coordinate, I'm going to call it x2, y2. Again, we know all coordinates are labeled x and y. And because this is my first one, that's why we put that little subscript 1. Since this is my second coordinate of x and y, I'm going to put that little subscript 2. So far, so good, hopefully. Now, if we look, with slope, we can find it, again, one of 3 ways. The second way is going to be using our slope formula. This is something we need to memorize. And this m is really important. Right now, we don't quite know what it means, but when we get to graphing linear equations, we will. But for right now, we're just going to say m means slope. And our equation is y2 minus y1 over, divided by, x2 minus x1. So using this first example, let's find our slope. So my y2, if we look, is -6. Minus our y1 is 3. So -6 minus 3 over x2 is 2 minus x1 is -4. Don't be alarmed by what's happening here. We're going to clean this up in a little bit. So now that we've substituted all of our values in, what we're going to do next is do some of the math. So if we look at this, we know that -6 minus 3 is -9. Then if we look at our 2 minus our -4, remember, when we're working with our negatives, we can always say that a double negative is really a positive, and that becomes a big plus. So we end up with 2 plus 4, which is 6. One of the things we have to remember about slope is that it will create a fraction. And what do we have to do with all fractions? That's right, simplify. So I can go ahead and divide both of these, numerator and denominators, by 3. And 9 divided by 3, or -9 divided by 3, will be -3. And 6 divided by 3 is 2. Once we have our slope in simplest form, we are done. Okay? Let's try another example using the same formula. Okay, and again, this is where we're going to get to some very interesting things. So looking at the formula, our next 2 coordinates are going to be -3, 5, and 4, 5. At this point, we should notice something kind of interesting. If we don't, that's okay. First thing I want to do is go ahead and label x1, y1, x2, y2. Next, I'm going to put them into my slope formula. So y2, we can see is 5, minus y1, we can see is 5, divided by x2, 4, minus x1, -3. Okay? Again, we're going to go ahead and clean this up. First, do we notice anything interesting right now? Hopefully we do. Let's go ahead and find the slope. Let's do the math. What's 5 minus 5? 0. And now, once we clean up this double negative action happening here, 4 plus 3 is 7. So why is this really interesting? Well, unlike our first example, we can see that we have a 0 in the numerator. This is a big, interesting point right here. This is something special. Anytime we see a 0 in the numerator, we know that this is going to end up being a 0 slope. This is actually our answer. So what does that mean? Eventually get to the horizontal line, this zero slope. Here we are, we got to it. Remember, that means if I saw this figure pictorially, it's going to be a horizontal line. Again, when we get to writing equations, we'll see why that's so important. Okay, so let's look at our last slope. Again, something interesting is going to happen here as well. Having some camera problems. Sorry. Okay, so our last slope are going to have the coordinates -4, 3, and -4, 2. Again, we should notice something interesting is happening here, but we might not notice it yet. Okay, so here we go. Let's put this into our slope formula. Our y2, whoops, I didn't even label it. So let's label it first. Okay, so our y2 is going to be 2 minus y1, we know is 3, over x2, -4, minus x1, -4. Again, we're going to clean this up in the math when we get to it. So first, 2 minus 3, hopefully we remember, that's going to give us a -1. Over, well, when we see this double negative, again, we can go ahead and make that a positive. And -4 plus 4, be very careful, that answer is going to be 0. Uh-oh, we have another 0. What does this mean? Well, this is going to be the other weird slope line that we saw when we were looking at our 4 types of slope. We can't have zeros in the denominator. If we went ahead and put -1 divided by 0 in our calculator is even going to give us an error sign. So what does this mean? Well, slope-wise, this means that we're working with an undefined line. We have this vertical line. If we plotted these points, we would see that it's a vertical line here. But since we didn't because we're graphing, we just know that it's going to be an undefined slope. Be very careful when you look at these two. A lot of people get confused. Remember, 0 in the numerator, 0 slope. 0 in the denominator, undefined slope. So be very careful with that. So the last way that we're going to find slope is going to be with an equation. So there's 2 types of equations that we're going to deal with as we work through linear equations. The first one is going to be by far our favorite one, the slope-intercept form of an equation. And that is y equals mx plus b. Have we seen this m before? Yes, we have. We know that that's going to be the same m that we saw when we were finding our slope with the formula. So that m, we know, is our slope. We're going to talk about all of these other letters when we get to writing equations and what those stand for. This is the next most important letter. And the second form that we're going to see linear equations written in is standard form. We don't normally see this as much as we see slope-intercept form. It's just not as useful to us. However, we will work with it, and I do want you guys to be able to find the slope here. Unlike a little m that we have in our slope-intercept form, standard form's slope is a little bit more disguised. The slope is actually -a over b. And again, we're going to see some examples of both of these. So let's start with our slope-intercept form right now. So the nice thing about this is when we look at our examples, hopefully they're easy to identify. The slope, when we notice in our slope-intercept form, is always in front of that x. It's going to be the coefficient of the x variable. So if we look, we hopefully notice what's in front of the x. Oh, well, this 4. Therefore, I know my slope is 4. What we notice is different about slope here than what we just saw when we were given 2 points or when we were working with rise over run is we actually have a whole number. If we want to, we can go ahead and make this 4 over 1 so that we can keep it a fraction. Doesn't really matter right now. Again, when we start graphing linear equations, we will want to know that these two mean the same thing. All right, so let's try another example. What if we have y equals -17x plus 8? Again, as long as we're in slope-intercept form, we know that the slope is always going to be in front of the x. So, what's our coefficient of x? That's right, negative 17. So our slope here is negative 17. Again, it's everything that's in front of that x variable, the negative and the 17. Okay, let's try one more example. This one's going to be a little tricky. We have negative x plus 1/2. Okay, earlier I said that our slope was going to be that coefficient that's in front of that x variable. Well, if we look, what's in front of that x variable? Do you even see a number here? Oh, guess we have to remember, when I don't see a number in front of the x, what does it mean it has to be? Oh, that's right, it's that invisible 1. So now that I put that there, am I able to identify the slope? Hopefully we know now that the slope would be negative 1. Okay, we're going to try one last example, and this one hopefully you guys feel comfortable with. Okay, so this is going to be y equals 2/3 x minus 1. Again, our slope is going to be that coefficient in front of that x, so our slope is going to be 2/3. Perfect. How do we feel about slope in slope-intercept form? Hopefully, not a bad thing for us. The next one, oh man, it's going to be a little rough. So if we look, standard form. So our standard form, not as friendly to us for finding slope as slope-intercept form. So we're only going to see a couple of examples here. The first one we're going to see is going to be 2x plus 3y equals to 7. So again, our cheat here for our slope in standard form is negative a over b. If we look, this time a is the coefficient in front of x, b is the coefficient in front of y, and c is just our constant. Doesn't have any variable there. So I'm going to quickly label these. Obviously, 2 is a, and 3 is going to be b, following the same formula. So now, all I'm going to do is have my negative ready. What's a again? That's right, 2. What's b? 3. So now I know my slope is negative 2/3. Hopefully that wasn't too tricky. We're going to get used to those coefficients. Okay, let's try one more of those. And we have 5x minus 4y equals 8. So again, we first want to go ahead and label our a and b coefficients. So let's do that. Now that we've done that, to find our slope here, we know is going to be negative a over b. So I'm going to put my negative sign here. What's my a? 5. What's my b? Negative 4. Uh-oh, something strange is happening here. What we should notice is that we have a negative divided by a negative. And we know just from our algebra rules that I can just cross those guys out, and I'm left with a positive 5/4. Normally we like to make this a mixed number because we're working with fractions, but because we've moved on to linear equations, we're going to keep this as an improper fraction. So we found our slope, 5/4. So that was our slope introduction. Hope you enjoyed it. We'll start working more on this in class. Bye.